Okay, alright, good evening class, alright, okay, so we are here at chapter 3. Okay, so the aim of the video, right, is to share with you guys, alright, what are the things to take note lah for chapter 3, the key terms and the concept lah, right. So chapter 3 is a easy chapter, right, it's mass, weight and gravitational field. Okay, yeah, this one will serve as you think of it as a prelude, alright, to chapter 4 lah, right, the one that we have done on Friday. Okay, so key terms, alright, these are the few terms to take note of, alright, mass, okay, weight, and as well as your gravitational field strength. Okay, so these three terms must know, alright. One thing to highlight, right, will be the gravitational field strength, alright. So the actual in real life, right, the gravitational field strength is measured to be 9.81 Newton per kg. Okay, but you can see, right, why people use 10, right, because of simple calculation, right. So it depends on the question, right, in your papers. Okay, if the question asks you to use 9.81 for calculation, you use 9.81. If the question did not ask, okay, you can use 10 Newton per kg. Okay, alright, and then after that we move on. Okay, we move on towards the different type of forces. This one I would say you take a look at your textbook. Is pretty it gives you quite a comprehensive description lah of the various type of force that you need to know. Alright, so textbook page 44 to 45. Okay, alright, so for non-contact force, the most common one will be gravity. Alright, this one you probably see it every time lah. Alright, magnetism and electrostatic not so much, probably in the later chapters. Okay, contact, okay, contact force, all four need to know, right, all four you need to know. Okay, alright, I want to highlight the difference between the friction and air resistance. Okay, so for friction and air resistance, right, don't mix it up. Alright, friction, you see it as the resistance, right, when two objects is rubbing together. Okay, for example, solid and solid, right, you have one block of wood, you rub them, right, got friction. Okay, alright, and usually friction generate what? Heat lah. Okay, alright, and then after that you also have solid and liquid. Alright, okay, so you compare running on a dry day versus running on a wet day. Alright, that one is friction lah, right, because on a wet day there's less friction ma. Okay, air resistance, right, is specific to air only, right. So you have the solid, okay, you have the solid with air, okay, you have the liquid with air. Alright, either way, right, air resistance, you think of it as friction. Okay, I'm careful with my words. You think of it as friction, but it's only specific to air. Okay, so I draw an example for you guys, right. Okay, it's this part. Okay, right, when you're running, okay, what is going against you? The wind, right. So the wind, alright, is blowing against you. That's what we call about air resistance. Okay, then after that, the friction is the one, right, that between your shoe and the ground. It is the one that helps you to push forward when you're running. Okay, so don't make things up, right. So air resistance is only specific to air, right. But of course, layman term, you can say air resistance is friction with air. But physics students, alright, you want to be a physics expert, okay, differentiate between these two. Alright, okay, and then normal force, we talk about it. Okay, this is probably also a very common one. Okay, and finally, right, you have tension. Okay, alright, so how does tension work? It has to do with pulling, right. When you are pulling an object, right, that is not flexible. Alright, so what do I mean? For example, tug of war, right, you are pulling a rope and the rope cannot stretch one. You are pulling a rope and the rope is cannot stretch. We call it taut lah, right, T-O-U-T. Right, we call it taut, T-O-U-T. Alright, okay, for example, during our activity, right, the lamp hanging on the ceiling, alright, and the thing that is supporting the lamp, right, the thing that's between the lamp and the ceiling, right, that's tension. Okay. In ancient times, right, when you want to transport thing to another, right, you use horse carriages, right, so then you have the horse, and then after that the horse will what, the horse will pull the carriage, right, so what happens is this: you are moving forward, right, you are moving forward. Okay, body A will pull B. Alright, body A will pull B. So body A, right, exerts a pulling force on B. Right? So we call it TAB lah. Alright? Okay? This is what we call the tension. Alright? So body A exerts a pulling force on body B. Alright? And then by Newton's third law, equal and opposing force, alright, acting on different bodies, right? So then body B will also exert a pulling force on body A. TBA. Alright? Okay? TBA. Okay? Alright? So this is how it works, alright? But y'all don't go and see that, oh, wow, one arrow on the right, one arrow on the left, they cancel, and then is the body moving. Right, remember, right, they are acting on different body. Okay, they are acting on different body. Right, because in real life you can see what, in real life these two things, when you pull A, they will move mah. No. Okay, but how does the physics work, right? We'll talk about in first law and second law. Alright. Okay, so these are your non-contact forces and contact forces. Important, why? Because you need these forces to draw your free body diagram. Okay, I give you a hint already. You need these forces to draw your free body diagram. Okay. Okay, the differences between mass and weight, right? Okay, I won't talk much. Okay, but to emphasize, okay, constant at any location. That's the mass. Means whether you're in Singapore or whether you're in Philippines, Norway, Arctic, right, at the ends of the earth, right, okay, it's constant. But for weight, it's different. Okay, so if you all right want to go, right, you all can go and research lah. Alright, for those of you who are interested, if I weigh 70 kg in Singapore, do I weigh more or do I weigh less in the Arctic, and why? Okay, alright, okay, you all can go and research, then you all can let me know. Okay, so another thing, right, scalar and vector quantity, right, and the units, alright, don't confuse. This one I see many people careless mistake on. So your units, alright, kilogram for mass, newtons for weight, because weight is a force. It's a kind of force. Alright? Okay, beam balance, okay, this is something that you probably have seen it before, right? So they say, oh, how do I compare? Right? Then you have 100 gram here, and then after that you keep on putting your things until, right, it balances out. The spring balance, alright, I think this one in your HPL they went through it, right? How does your digital weighing scale works? Okay, so weight is related to the mass of an object. Okay, so the weight, alright, will be equals to mass times gravitational field strength. Alright, so your mass multiplied by your gravitational field strength will give you your weight. Okay, so we practice a bit. Alright, so they give you the weight of an object on the moon, they're asking you the weight of the object on Earth. Right, so then what we do, right, is that we take the weight of the moon divide by the gravitational field strength of the moon. Okay, you get 13.5. Okay, so this 13.5 kg is the mass, constant at any location. Then you want to find the weight of this object on Earth, right? You take the mass multiplied by the gravitational field strength of the Earth. Then you get 135. Okay? Right? So this is more or less that's it for this chapter. Okay? But this chapter, right? This chapter, how you understand this chapter will influence how you understand chapter 4 also. Okay? Alright, so so don't just anyhow do lah, right, for the worksheet. Okay? Right? Because we are talking about, but because at the end of the day, this one relates to forces. Alright, and forces is a very, very, very fundamental part of physics. Alright, okay, alright, so that's all. Alright, I don't want to make the video too long. Alright, I will see you guys on Tuesday. Alright.